This is part one of the series, The Basics of Geometry. This is going to be our entry point into the study of Euclidean geometry, or sometimes called planar geometry. Euclidean geometry is based on the collection of works by Euclid, who published the work The Elements sometime around 300 BC. And the Elements contained much more than just geometry, but the bulk of what was known in the day that we now call planar or Euclidean geometry is based on what Euclid penned in that work. It wasn't just Euclid's work. He compiled the works of all known philosophers before and contemporary to him and put it all together into one collective volume. So that's what we're about to start studying. And the study of geometry is a technical discipline. And with all technical disciplines, there is a specific language that goes along with that discipline. And geometry is no different. There is a special language that we're going to have to learn that is based on a set of words. And the fundamental set of words that the geometric language we're going to talk about is based on is called undefined terms. Undefined terms are terms that have no formal definition, but there is agreement on what they mean. The three fundamental undefined terms that we're going to use throughout this course is point, line, and plane. And we're going to look at the descriptions, or what do these things mean? What do each one of these words mean? And then we're going to build on those words to create more complex language to describe everything that we're going to be working with. The first of our undefined terms is point. A point can be described as an object with no dimension. It simply references or refers to a location in space. It has no length, no width, and no height. So realistically, points cannot actually exist in our three-dimensional universe. But we can represent points. Points are represented by dots. If you make a mark on a piece of paper, that little point mark is a point, or a representation of a point. A pinhole in a piece of paper. The joining of three faces of a sharp countertop that would poke you if you walked by it and hit it, that can be a representation of a point. Now, to name points, we generally refer to points with some capital letter. In this case, we have the capital letter P associated with this yellow dot. We would say that that is named point P. You would say the word point followed by the letter P. It would be inappropriate to say the name of this point is P. You would have to say point P. If you were writing on a sheet of paper, it would have to be point P, not just P. And this may seem like a trivial detail, but what you're going to learn throughout this course is that geometry is all about the trivial little details. What we consider at this point to be trivial, they're extremely important details, because many important concepts differ by only slight details. So that's a point. The next item in our list are lines. A line is an object with only one dimension, length. It has no width or thickness. Again, just with points, lines can't actually exist. Lines are straight objects that go on forever, and they're generally represented by these straight things with arrowheads on either end. These arrowheads indicate that that object goes on forever in that direction and forever in that direction. And there are generally at least 2 points on any given line. A line must have at least 2 points because that's how we name lines. We can pick any 2 points that are on the same line, and those could be the name of that line. For example, in this line, we could say it's line, notice the straight piece here with the 2 arrowheads going to the left and the right, and the letters A, B. We could also say that this is line BA, because this line is the set of all points extending into infinity to the left and to the right. So it really doesn't matter which one we use. We can say AV or BA. So this would be line AB. We could also say line BA. But it's very important to note the symbolism here. This is the geometric symbol. The English translation of that symbol is line AB. The next item is plane. A plane is an object with two dimensions, length and width, but it has no thickness. Think of this as an infinitely thin sheet of paper that extends infinitely to the left, the right, the top, and the bottom. The representation of this is generally a shape that looks like this, a four-sided shape that has four edges. Now please don't get confused by these edges. They really don't exist in an actual plane. These are just representations. Think of this as a window into a larger viewport. Think of this as you were looking outside of a car. You would only see this much of the overall reality that's outside of your car. These limits do not actually exist in an actual plane, but we need something on a sheet of paper to represent what we're talking about. So a plane is a flat surface that extends infinitely in two directions, and it's represented by something that looks like what's called a parallelogram. We're going to learn that a lot later, but the word plane must precede the name of all planes. And what we can do is we can pick any 2 points in that plane that are not on the same line. So here we have point R and point S that are on the same line, and point T is a point not on the same line. So if we wanted to, we could call this plane RST. We could also call this plane TSR, or RST, or RTS, STR. Any order of those 3 points would be perfectly fine as long as we put the word plane in front of it. So here we have plane RST and plane STR. Now it's very important to note, sometimes you will see an italicized letter off to the side or in a corner of a plane. This is also an auxiliary identifier for the plane. So we could say this is plane P, and you would write it just like this, plane P. Now remember, this is an identifier. This is not a point. There is no point associated with this letter. So it would be inappropriate to say that this is plane RSP, because this is not a point. So in recap, a plane must be named with any 3 points that are not on the same line, or with an italicized letter associated with that plane. And always those letters must be preceded by the word plane. So plane P, plane RST, plane STR. Up to this point, we've been using the phrase points on the same line, points not on the same line. Let's get into that in a little bit more formal detail. Here we have a representation of a plane, and we have a line inside the plane, and here we have a line that's going through the plane. What you see here is this part of the line is above the plane, and it hits the plane right here, and you can see this dotted segment, this dotted piece is intended to represent that that portion of the line is behind the plane, and this portion peeks out from underneath the plane. Now realistically, of course, as we said before, since this edge comes on forever going in both directions, we actually would never, once the line went through the plane, we would never get to see it peek out again, because this extends through infinity. But just work with the idea here that this is a separate window representing a plane, into the universe just to get us a three-dimensional outlook on this figure. We have a capital letter P associated with this plane and several points. These 2 points, R and S, are on the same line. We would say that those 2 points are collinear. Collinear points are points that are all on the same line. So in the diagram here, RS are collinear, V, T, and U are collinear. You would say that points R, S, and T are non-collinear. And the reason that they're non-collinear is because all the points listed must be on the same line to be collinear. So points R and S are collinear, R, S, and T are non-collinear. Again, point V, T, and U, those are collinear points. V, T, U, and S are non-collinear. V, T, and R are non-collinear points. So all points listed being on the same line, those points are collinear. If all the points listed are not on the same line, they're non-collinear. All right, let's move on to planar, points being in the same plane. Here we have point R, S, and T are all on the same plane. We would say that those points are coplanar. All points that are on the same plane are called coplanar. Points R, S, T, and U are non-coplanar because all 4 of those points are not on the same plane. This point is clearly above the plane. Also, you could say S, T, and V are non-coplanar. S and T are coplanar, but S, T, and V are not on the same plane because V is below the plane, since this line is sticking through from top to bottom. So that is collinear, non-collinear, coplanar, and non-coplanar. Now, to put a more formal definition to the terms we had before, we would name a line with any 2 collinear points. We would name a plane with any 3 non-collinear points. So you name a plane with any 3 non-collinear points and name a line with any 2 collinear points. Again, technical details, but still important nonetheless. Let's move on to the next topic. Now, if points, lines, and planes were all we needed to describe a geometrical system, our lives would be fairly simple. But we're going to need to build a much broader vocabulary to describe the various things we're going to be dealing with in geometry. The way we do that is using what's known as defined terms. Defined terms are terms that can be defined using undefined terms and other known words. So our undefined terms, point, line, and plane, are going to form the basis for our set of defined terms that is what we're going to be describing for the rest of this course. I don't want to break up the continuity of the discussion by splitting the description across video boundaries, so I'm going to begin our description of our first defined term in the next video. So I will talk to you in the next video.